Everything I said yesterday about the different cases is all true. That we could have a case where we get no triangle because the side's not long enough to reach. We could have a case where we have one triangle and it actually turns out to be a right triangle because the height has to be the same as the missing side. Or we could have a case where we get two triangles, where we could have a length that could swing in two directions. Now, the way we can determine it is a lot easier than what I told you yesterday. But everything about the different cases is true. So I'm just going to leave that the way it was and think about teaching it that way. Or like explaining to you what the differences are that way. But actually finding them is easier to do. And we're just going to draw our triangles just like we always do with the given information. And then we're just going to trust the trig to tell us which case we have. We don't have to plan ahead. So, if I was drawing this triangle, I've got alpha here, which is 41 degrees. Okay, so across from alpha is side A. Well, it tells me side A is 3.3. So I put that over there. I know side B is 5.4. So this has to be angle beta. And then I don't know angle gamma or side C. We did, but I didn't show you the way that I want to show you now. I'm going to show you a different way that works on all of them, no matter what the case. I would learn it this way. Okay, so for law of sines, we have a pivot case, the one that is already filled out for us. So in this one, that would be this angle, alpha, with this side, 3.3. So I'm going to write down sine of alpha over A. Now, before we got to choose either side we wanted to. Now we can't. We can't choose side C and angle gamma because we know neither one of those. So that would give us two unknowns. So we have to use angle beta and side B because that's only one unknown. So when I set that up, that's going to be sine of the angle beta over B, which is 5.4. Now we've got a proportion. We're going to cross multiply and solve for beta. So this is going to give me 3.3 times sine of beta equals 5.4 times sine of 41. Okay, so now we're going to solve for beta. So I divide by 3.3. So that's going to tell me sine beta equals this number. But I don't really care what sine of beta is. So if I was going to solve this, I would go ahead and take an inverse sine of both sides because I want to know what beta is. So in my calculator, I'm going to put the inverse sine of, and then what I have circled there. So I have the inverse sine of 5.4 times sine of 41. And that's going to be divided by 3.3. Close my parentheses. And I get error. Because beta does not exist. There is no angle beta that can make that true. Therefore, there is no triangle. So, this is something I'm going to do just this time, just to help teach it. But you don't have to do this. So if I put back in 5.4 sine of 41 divided by 3.3, I get 1.073. So what we're saying is sine of some angle has to be 1.0735. Think back to when we graphed sine waves. What was the maximum and minimum values for the range of sine? -1 to 1. Sine has to bounce between -1 and 1. Well, because here I need sine to be something bigger than 1, it's not possible. It's not even available in the graph. So that's why we get an error when we try to take the inverse sine of this, because it does not fit into the sine wave. Therefore, there's no triangle. Okay, so this one, I've got gamma is 125, B is 5.7, C is 8.6. Now, it tells me that only one triangle can be drawn, but I know anytime I'm given an obtuse angle, it's either going to be one triangle or no triangles every time. Can't be any other option. If I'm given the obtuse, well, I don't want to say that. I'm pretty sure it can only be one. So let's just set it up. So it's an obtuse triangle. So I need an angle that's greater than 90. So this has to be my gamma, which is 125 degrees. Across from gamma is side C, which is 8.6. Now I get to choose where B goes. It doesn't really matter. I'll put B here as 5.7, which means this is angle beta. And that leaves this as angle alpha and side A. So right now the only thing I can find is beta. So I'm going to set up my sine using the pivot ratio, which is sine of 125 over 8.6 equals, and I'm going to solve for beta. So that's going to be sine beta over 5.7. Now cross multiply. So I've got 8.6 times sine of beta equals 5.7 times sine of 125. I'm going to divide by 8.6. Those cancel. So I'm left with sine of beta equals this. Well, I want to find out what beta is, so I'm going to take an inverse sine of both sides. So when I put that in my calculator, I have the inverse sine of 5.7 times sine of 125 divided by 8.6. And when I do, I find beta is equal to 32.88 degrees. So on your homework, it'll tell you what to round to. I'm just going to round to 2 decimal places. But it'll tell you nearest tenth, nearest degree, and you just do whatever it tells you to do. Now, when we discover an angle, this is where we have to determine if it could be 2 cases or 1. So because we are looking, so this is just a teaching point. This is not something you have to think. You need to think through this every time, but you don't have to do this every time. I took an inverse sine of an angle. Inverse sine is only defined for the first and the second quadrants. Sorry, the first and the fourth quadrants. Because we have to look for everywhere it's positive and negative. And we restrict the domain. So we've went over that already. Because this ratio was positive, that means it had to put me in the first quadrant. But in reality, this angle could be a reference angle in the first quadrant or the fourth quadrants, because sine is positive in both. So when you use the law of sines, this is where your 2 cases could come into play. So if this was a rotation of 32.88 degrees, what would I have to rotate in order to make this be a central angle of 32.88? I would have to have rotated all the way to there, just short of 32.88, which is 147.12. So really I have 2 cases every time. My beta could be 32.88, or it could be 147.12. However, a triangle is only allowed to have 180 degrees in it. So sometimes one of these cases might eliminate. So when I look here, 147.12, and I already have a given angle of 125, that's going to be more than 180. If I add those up, I get something more than 180. So therefore, this is not a valid case. This is my only possible case. Thus, one triangle. So now I know beta is 32.88. I know two of the angles, so I can find the third angle, alpha, because all the angles have to add to be 180. So I could do 180 minus 125 minus 32.88, and I get alpha has to be 22.12 degrees. So now I know all three angles, so I can use the law of sines to find my missing side A. So I go back to that same pivot ratio. I've got sine of 125 over 8.6 equals, it's going to be sine of alpha, which I now know alpha is 22.12 over A. Now we solve for A. So I've got A times sine of 125 equals 8.6 sine of 22.12. To get A by itself, I need to divide by sine of 125. So notice this time I didn't have to take an inverse trig function because the variable was already isolated. I was not taking a trig function of that variable. You want to put that in my calculator, 8.6 times sine of 22.12 divided by sine of 125. I get A has to be equal to 3.95. So my answer here, there's my missing side. There are my two missing angles. When is the Pythagorean theorem available to be used? In a right triangle. This is not a right triangle, so no, you can't use a Pythagorean theorem. Okay. So when I draw this triangle out, I've got beta, which is 38 degrees. Across from beta is side B, which is 6.4. It tells me C is 5.9. So across from C has to be angle gamma, which leaves me with angle alpha and side A. So I already have one angle and its opposite side finished. It's the 38 and the 6.4. So that's going to be my pivot ratio. I've got sine of 38 degrees over 6.4 equals, now I have to choose the angle that already has a side found. So I have to find gamma first. So it's going to be sine of gamma over 5.9. Cross multiply. 6.4 sine of gamma equals 5.9 sine of 38. I'm going to divide by 6.4. So that tells me sine y equals this fraction. But I don't care what sine y is, I care what y is. So I'm going to take an inverse sine of both sides. So I'm going to get gamma equals, and then in my calculator, inverse sine 5.9 times sine 38 divided by 6.4. When I do that, I find gamma is 34.58 degrees. Okay? So now, we have to find out, could another angle work? Because it could also be in the second quadrant because sine is also positive there. So we're going to do 180 minus the angle we found, which is 34.58. When I do that, I find gamma could also be 145.42. So if I did 145.42 plus 38, I get 183.42 degrees, which already exceeds our limit of 180 degrees inside of a triangle. Therefore, this cannot be valid. Another way that I knew that angle wasn't valid this time is because across from my 38-degree angle was a 6.4. This angle had a 5.9, which is a smaller side length, so this angle has to be smaller. It can't be larger than 38. So I knew before I even did the test it wasn't going to work, but the test will always tell us. So just another way to confirm I'm thinking correctly. So this one only has one case. It's where gamma is 34.58. So now if I know gamma is 34.58, I can find alpha because I know two of the three angles. So I would do 180 minus 38 minus 34.58. That's going to give me 107.42. So now I know alpha. Now the last thing to find is side length A. So I'm going to have to use the law of sines again. So I go back to my pivot ratio, the one I had at the very beginning, sine of 38 over 6.4. And now I'm going to use it with the sine or the angle alpha and side A. So that's going to be equal to sine of 107.42 over A. Cross multiply. A times sine 38 equals 6.4 times sine of 107.42. Now solve for A. So I'm going to divide by sine of 38. Now A is isolated, so I put that in my calculator. 6.4 times sine of 107.42 divided by sine of 38. I get that side length A has to be 9.92 length. So I now know gamma, alpha, and side length A. Okay, so here, when I draw my setup, beta is going to be 56.3. Across from angle beta is side B, which is 7.6. I'm going to make this side A 8.3. So that means across from that is angle alpha. And I'm also going to have to find angle gamma and side length C. So my pivot ratio, the one that I know, is sine of 56.3 over 7.6. I have to pick the other known thing that I have, which is 8.3. So I'm going to be looking for sine of alpha over 8.3, cross multiply, 7.6 times sine of alpha equals 8.3 times sine of 56.3. I'm going to divide both sides by 7.6. Now that's going to give me what sine of alpha is equal to. So in order to find alpha, I have to take an inverse sine of both sides. So now I find alpha is equal to, and in my calculator, I'm putting the inverse sine, 8.3 times sine of 56.3 divided by 7.6. I found that alpha is 65.3 degrees. But because sine is positive in the first and second quadrants, it could just have a reference angle of 65.3. So the other possibility could be found by doing 180 minus 65.3, which means alpha could also be 114.7. Now we want to make sure that that second case is valid, so we would do 180 minus 56.3 minus 114.7. So you don't always have to do it that way. I guess normally I just add them up. If I add 114.7 and 56.3, I get 171, which means there's still 9 degrees left for that last angle. Therefore, we could have alpha being 114.7, and that would give me gamma being 9, because there's 9 degrees left. Or if alpha was 65.3, then gamma would be something else. So I would do 180 minus 65.3 minus 56.3. I get gamma could be 58.4. So this is the case where there's two triangles. Okay? So now I have to find side length C for each case. So I'm going to start with case 1. So my pivot ratio is sine of 56.3 over 7.6 equals, and now I'm looking for side length C, so it's going to be sine of gamma, which is 58.4 over C. And we solve. So you've probably already seen the pattern. That's going to be 7.6 times sine of 58.4 divided by sine of 56.3. Is everybody okay with me doing that? Just saves me from writing because I don't have a lot of room anyways. So if that was the case, I find that C is equal to 7.78. Everybody's good with that? How I came to that conclusion? Solving. Okay, then I have to do the second case. What if gamma was 9? So I would have sine of 56.3 over 7.6 equals sine of gamma, which is 9 over C. So again, I'm going to cross multiply and solve. So that's going to give me 7.6 times sine of 9 divided by sine of 56.3. which means side length C could be 1.43. Okay, so if I look at this one, it tells me to solve the following triangles. So number one, I know the three sides. So this is going to be the side case. So we're going to start by finding the largest angle first. So when I set this triangle up, I'm going to call this the largest side 10.8. So that means this is gamma across from it because it was C. And it doesn't really matter which other side you make where. So I'll make this 8.2, which means this one is alpha. And then B here is 3.7. So my missing angle there is beta. Okay, so because we're dealing with side, we're going to find this largest angle first. So the largest angle will happen across from the largest side. So I'm going to first find gamma. So again, that means this side is the one that's isolated. So I can think about it as being the last formula, c squared. So when I start plugging in, that's going to be c squared equals, now we square the other two sides. So a squared would be 8.2 squared plus b squared, which is 3.7 squared, minus 2 times a, which is 8.2, times b, which is 3.7, times cosine of gamma. And sorry, I just realized I didn't plug in here. I know what my c is, right? That's just the missing side, so that should be a 10.8 squared there. Okay, so now we're going to have to solve for gamma, get gamma by itself. So again, I like to do everything before I ever put it in my calculator. I like to put everything in my calculator at one time. So you don't have to do it that way, but for me, I would move both of those over. They would become negative. And then I'm going to divide by negative 2 times 8.2 times 3.7. So what it's going to look like in my calculator, I'm going to have 10.8 squared minus 8.2 squared minus 3.7 squared. And then I have to divide all of this by negative 2 times 8.2 times 3.7. And so that would be equal to cosine of gamma. But I don't care about cosine of gamma. I want to know what gamma is. So I'm going to take an inverse cosine of both sides. Is everybody okay with me doing all those steps at once? Or is that too many? Yeah, that's what I figured. So I'm going to put that in my calculator. I've got the inverse cosine of, and now I'm going, in mine, I'm going to have to put parentheses. If you're using your Casios, the first thing I would do, inverse cosine of, I would put this fraction bar. You start with that. So make sure you have this fraction bar here, and then put this in the numerator and that in the denominator. Does anybody not have the Casio? using something different? Okay, so just me. So I'm not going to go over that nuance. So I get 10.8 squared minus 8.2 squared minus 3.7 squared. That's on the numerator of my fraction. Then in the denominator I have negative 2. Oh no, that's the wrong thing. Negative 2 times 8.2 times 3.7. No, that's not what I want to see. So now I found the biggest angle. So I know gamma is 126.05 degrees. So now I know one angle. And so I would go through, find the next angle. So it doesn't really matter which one we find. I'm going to choose alpha because I normally go alphabetically. So to find alpha, I'm going to now use the law of sines because I now have a pivot ratio. I know gamma and c. So I could say sine of gamma, which is 126.05, over c, which is 10.8, has to equal, and then again I'm going to be looking for alpha, so it's going to equal sine of alpha over 8.2. So now solve that out. So I've got 10.8 times sine of alpha equals 8.2 sine of 126.05. Now I need to divide by 10.8 on both sides. And then I'm going to take an inverse sine of both sides. And so that's going to give me alpha equals, and then in my calculator, I've got the inverse sine of 8.2 times sine of 126.05 in the numerator, and that is going to be divided by 10.8 in the denominator. And so I found alpha is 37.87. Okay, so remember, when we find an angle using law of sines, we have to check for two cases. So the second case will be alpha equals to 180 minus 37.87, which means alpha could be 142.13. But you'll notice, because this is obtuse, there's no way this could be a case. So that one won't work. But I just wanted to make sure I put that in there because you still have to do that even on these problems when you find your first angle using law of sines. So my only possible alpha is 37.87, and so now I can find beta. So we find beta by subtracting from 180 because we know all the angles have to add to be 180. So I subtract 126.05 minus 37.87, and that tells me beta has to be 16.08 degrees. Okay, so here's another example of side, 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 where we're given the three sides. So when we have side, 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 we must find the largest angle first. So if that's 9.6, then the angle opposite that is beta. Then I am given 7.7, so the angle opposite that is gamma. And then 3.8, opposite that is alpha. So I have to find beta first. So I'm going to use that second formula, which is b squared. So it's going to be 9.6 squared equals a squared plus c squared minus 2 times a times c times cosine of beta. Okay, again, I'm going to do like I did last time. I'm going to do all my solving at one time and then put it in my calculator. So I'm going to move these over. So I've got 9.6 squared minus 3.8 squared minus 7.7 squared. That's going to be divided by negative 2 times 3.8 times 7.7. And that would be equal to cosine of beta. I don't really care what cosine of beta is, so I'm going to take an inverse cosine of both sides. And here we go. So I've got the inverse cosine of, in the numerator, I have 9.6 squared minus 3.8 squared minus 7.7 squared, divided by, in the denominator, I have negative 2 times 3.8 times 7.7. Okay, so when I did that, I found beta. Let me use the same color. So beta is black. Beta equals 108.36 degrees. Okay? So now I know beta. I just have to find one of the other two sides, or angles, sorry. One of the other two angles. So I am going to find alpha. So I've got sine of beta, which is 108.36, over A, which is 9.6, equals sine alpha over 3.8. Cross multiply. So I've got 9.6 times sine alpha equals 3.8 times sine of 108.36. Divide by 9.6. And then I'm going to take an inverse sine. So that's going to give me alpha equals the inverse sine of 3.8 times sine of 108.36 divided by 9.6. I find alpha is 22.07 degrees. So again, when we find an angle using sine, we always have to account for two cases. It could be in the first and second quadrants. First or second quadrants. So I know it's not going to be in the second quadrant though because beta is obtuse. So again, my second case is not going to be valid because it's going to give me something over 180. So this is the only valid case of alpha. And so now I find gamma, which I use red for, by just subtracting. So I do 180 minus 108.36 minus 22.07. And that gives me my third angle, which is 49.57 degrees. Okay, so on this one, I've got two sides and the included angle. So this would be the side angle side case. So I'm going to draw it, set it up. So I'm going to draw this as my angle that I know. So that means the side opposite of that is A. Now, apart from that, it doesn't matter which one is B or C. So I'm going to call this one B, which means it is 5.8. Use a different color. And so across from the 5.8 is my angle beta. And that means the other side is C. So across from it is my angle gamma. So now I have to use this as my unknown side when I use the law of cosines, because I cannot use the law of sines because I do not have a pair that matches. I'm missing one from every pair. So I'm going to use the law of cosines with this known angle. So that means this is my isolated side. So I'm using the first formula, which is a squared equals b squared plus c squared minus 2b c times cosine of alpha, which this time we know alpha is 39.5. So now to find A, I need to take a square root of everything, right? Because that's telling me what A squared is. So if I take a square root of all that, it'll give me A. So I've got A equals, and then that's what goes in my calculator. So I've got the square root of 5.8 squared plus 3.6 squared minus 2 times 5.8 times 3.6 times cosine of 39.5. And so I find that my missing side A is 3.8 units. Okay, why is that? There we go. So I've got A is 3.8. So I have a side that's smaller than that, which is 3.6. So if you'll remember back when we have side angle side, when we first use the law of sines, we have to find the smallest unknown angle first. So since C is my smallest side, I'm going to find gamma first. So I'm going to say sine of alpha over A equals sine of gamma over C. Cross multiply. So I get 3.8 sine gamma equals 3.6 sine of 39.5. And now to solve that, I'm going to divide by 3.8 and then take an inverse sine. So in my calculator, I have the inverse sine of 3.6 times sine of 39.5 divided by 3.8. And I find that gamma is equal to 37.06 degrees. Okay, so my other possible case would be gamma could be equal to 142.94. Okay, so I did 180 minus 37.06. But if I had 142.94 and I added 39.5 to it, then I would have 182 degrees already accounted for. So that's too many. So that cannot be gamma. So this one only has one case as well. So gamma is 37.06. So now I only have one missing angle, which is angle beta. And so we can do 180 minus the two known angles. So I'm going 180 minus 39.5 minus 37.06. And that means beta is 103.44 degrees. Okay, so on 4, again, I've got side angle side. I've got two side lengths and then the angle between them. So I'm going to let this be beta, which is 10.5. Across from beta is side B, which I do not know. I'm going to let this be A, which means that angle is alpha. And then this would be angle gamma. And across from that is side length of 2.4. So now I'm going to use the law of sines. Again, this is my unknown side, and this is my given angle, so this has to be the angle included. So I'm using the second formula, which is b squared equals a squared plus c squared minus 2 times a times c times cosine of the angle, which is 10.5. And now to solve for b, it's currently being squared, so I'm going to take a square root. And so when I do that, that's going to give me b equals the square root of 6.8 squared plus 2.4 squared minus 2 times 6.8 times 2.4 times cosine of 10.5. So I found b is equal to 4.5. So now given that information, I can now use the law of sines, using that as my pivot angle. So I've got sine of beta over b equals, and now I have to use the smallest side next. So that would be 2.4. So I'm going to be finding gamma. So that's going to be sine of gamma over 2.4. Cross multiply. That gives me 4.5 sine gamma equals 2.4 sine of 10.5. I divide by 4.5. That tells me what sine of gamma is, but I don't care what sine of gamma is. I just want gamma. So I take an inverse sine of both sides. So that's going to give me gamma is equal to inverse sine of 2.4 times sine of 10.5 divided by 4.5. That tells me gamma is 5.6 degrees. Pretty small angle. So again, so the other possibility for gamma would be 180 minus 5.6, which would be 174.4. But if it was 174.4 and this one was 10.5, I would already have too much. So that one's not a possibility. So 5.6 has to be my gamma. And then I have to find alpha by doing 180 minus. So we go 180 minus 5.6 minus 10.5. Which means the missing angle is 163.9 degrees. Okay, so if I look at 5, I've got B equals 28.9, C is 31.6, and alpha is 30.4. I'm going to assume that's supposed to be degrees. Okay, so I set up my triangle. So if alpha is 30.4 degrees. So I'm giving side here. Good call. Huh? Because when I backed up, it erased it. Because I was going back to take off the degree sign because I was wrong. And so I just got, it's just like undo. I've got undo, undo, undo. Yes, I would not have to delete that triangle. Okay, so if this is A, then that means this is alpha. If this is B, then this one is beta. And C, which means this one is gamma. So again, law of cosines. I want to find my largest angle first. Which would be gamma because it has the largest side across from it. So I'm going to set this up as the last form, which is C squared equals A squared plus B squared minus 2 times B times A. I did that out of order. That's okay. Times cosine of gamma. It's now to solve for gamma, so I'm moving these two terms over. So it's going to give me 31.6 squared minus 30.4 squared minus 28.9 squared. And now I have to divide by this junk, so I'm going to divide that by negative 2 times 28.9 times 30.4 is going to be equal to cosine of y, or gamma, sorry. But I care what gamma is, so I need to take an inverse cosine of both sides. And so that's going to give me gamma equals, and I'm putting all that in my calculator, so I've got the inverse cosine of 31, hold on, I gotta put fraction bar, 31.6 squared minus 30.4 squared minus 28.9 squared. And then in my denominator, I have negative 2 times 28.9 times 30.4. So I found that gamma is going to be 64.3 degrees. Okay, so now I have to use the law of sines to find another angle. So let's just find beta, because I think it's going to be the smallest. Even though that doesn't matter this time, I'm just trying to get myself in the habit of that. So it's going to be sine of 31.6, nope, I'm an idiot. Sine of 64.3 is the angle over the side, 31.6 equals, that's the one that I know them both. And now if I'm looking for beta, that's going to be sine of beta over b, which is 28.9. Cross multiply. So you get 31.6 sine beta equals 28.9 sine 64.3. Divide by 31.6. And now I've got sine of beta, so I would take an inverse sine of both sides. And so now in my calculator, I'm putting the inverse sine of 28.9 times sine of 64.3 divided by 31.6. So I find that beta is equal to 55.5. And so I'm thinking here we're not going to have to check for a second case. I think that's why we are doing them in the order that we are, finding the largest angle first. Because if I do 180 minus 55.5, that gives me 124. But 124 and 64 puts me over 180. So that means the only valid case, again, is 55.5. And so now I know two angles, and I'm looking for alpha. So to find alpha, we can do 180 minus the two known angles. So I'm 180 minus 64.3 minus 55.5, which means alpha is 60.2 degrees. Even though originally in the problem it told me alpha was 30.4. Wait, no it didn't. That was an A. Questions?